Hey guys, we're going to go over your homework from last night so that you can make sure you know what you're doing before your actual big quiz tomorrow. I already posted another video. This will be the second one. Some of you guys asked if I could go over the homework problems. Since we had a short day today, we weren't able to do that, but I'll go over them now. Okay, so first thing, estimate the area that would be covered by all 25 pennies. Okay, well, if the area of one penny is 3.14 square centimeters, when they say estimate, I mean you could just take the 25 pennies times 3. That'll give you a rough estimate of about 75 square centimeters. That's what that means whenever it says estimate. Then the next part says use 3.14 to find the area that would actually be covered by 25 pennies, and then compare it to your estimate. So instead of 25 times 3, you take 25 times the actual 3.14 that they already showed you was the area, right, of one penny. Well, there's 25 of them, so instead it'd be 25 times 3.14, which I believe is something like 78.5, maybe exactly 78.5 actually. That's still centimeters squared or square centimeters, okay? The next part, Marcella and Carlos repeat the same game using dimes instead of pennies. Each dime has a diameter of 0.7 inches. Carlos can count 15 dimes to the nearest hundredths of a square inch. What area do his dimes cover on the page? Okay, so since diameter is 0.7, we need for area, we need radius. So instead of 0.7, we need 0.35, which is half the diameter. So next we're going to square 0.35, right? And then we're going to multiply whatever we get there times pi, right? Okay, well that equals 0.35 squared is 0.1225. Still need to multiply it by 3.14. And there you get 0.38465. Okay, now that's the area of one dime. He's got 15, so they want to know the total area of all of his dimes, so we need to multiply that number by 15, and you get 5.76975, and that would be, it's in terms of inches, so that would be square inches, or inches squared. Okay, so that'd be your answer for that one. Okay, next page. So first problem here, we've got Donna bakes biscuits on a rectangular cookie sheet, 30 centimeters by 50. Each biscuit has a diameter of 8. What's the maximum number of biscuits that she can bake at once on one cookie sheet? So first I would draw out the cookie sheet. Okay. You got 50 by 30. Okay. So if each circle, each cookie, or biscuit I guess, has a diameter all the way across of 8, we got to think how many of these that are 8 wide can fit going up and down first. Well, you can make 3 whole out of 30 across, right? If there's 30 total, this would make 8, 16, 24, right? Another 8 would put you too much. You couldn't fit a fourth biscuit on that side of 30. Now you gotta go sideways, 50. If each one's 8, how many 8s go into 50? Well, 8 times 6 is 48. Okay, you can't fit another one on there, so it's 6 across, right? So it's 1, 2, 3, 4, 5, 6 across. And then you got to fill in 6 across for each row there. And it says, what's the maximum number of biscuits? Well, you got 3 by 6, 18 biscuits, right? If Donna bakes the maximum number of biscuits, what area do the biscuits take up on the cookie sheet? And explain. Okay, well, if each biscuit is 8 in diameter, that means the radius is 4. Area, remember, is pi r squared. So we need pi times 4 times 4. Or 16 pi. If they told you to leave it in terms of pi, that'd be great right there for one of them. But they don't. So you need to take 16 times 3.14. And you get 50.24. Now, again, that's just one, right? That's one biscuit, 50.24. How many do we have? We've got 18 of them. So now you've got to take that 50.24 times all the biscuits, 18 of them, and you get 904.32. And that would be centimeters squared, because it's area. Okay? Alright, next one. Find the area of the unshaded part of the figure. Okay, first we need to find the shaded part, right? We need to find the area of everything in total, and we need to find the area of the shaded part. Okay, so in the other video we went over one. We've done a few of these in class. If you notice, it's 20 all the way across, but there's 4 circles in there, right? 2, 3, 4, so that means each diameter is 5, 10, 15, 20. So each diameter is 5. But whenever you're working with area, we need pi r squared. We need radius. Well, 5 is the diameter, so now we got to cut that 5 in half. Right? So the area of this is equal to pi times 2.5 squared. Okay? Now, with this, you take 2.5 squared first. You get 6.25 times pi. If they told you to leave it in terms of pi, you're good there, but they don't. So you need to take 6.25 times 3.14. You get 19.625. Well, that's the area of the shaded. They want the area of the unshaded. Well, you're looking at this rectangle. It's 20 across. That's the base. And you're sitting there thinking, the height's not given. We don't know the height, so we can't find the area of the whole thing in general. But actually, they do give you the height. If the diameter's 5 going this way, then the diameter's also 5 going this way on these circles. Okay, so it's actually 5 for the height of this rectangle. So now you got 20 times 5. Okay. And that gets you a total of 100. Right? So the whole thing in total is 100 square inches. Okay? One circle is 19.625. So we need 4 of those. Get you to 78.5. Oops. 100 is the whole entire area. Well, you got to take away those shaded parts, those circles. And in that case, you would get, let's see, 21.5, I believe. 21.5 inches squared. That's the area of the unshaded portion of that figure. Okay? Alright, last one. So this one really gave a few of you troubles. Alright, a circular garden has a diameter of 6 feet. There are 2 sections of blue flowers and 1 section of white flowers. So they show you the outer section here is blue, then it goes white, then it goes blue again. What is the area of the section with the white flowers? Okay. So first thing we need to do is find the area of the whole thing. So the whole circular garden's diameter is 6. Well, that means the radius is 3. And that means radius squared is 9. So you have 9 pi for the area of the whole thing. Okay, if you take 9 times 3.14, you get 28 28.26. Okay, now you need to find the area of the white part. Okay, well, if the area, or if the length right here is 1 foot, that means the rest of it, if the whole diameter, sorry, I need to erase this. If the whole diameter is 6, okay, and you're taking away 1 foot here, well, you're also taking away 1 foot from that side, so you're really taking away 2 feet. That means the diameter of that white part is 4, right? Because it takes away from both sides of it. So you got 1 foot here, 1 foot here. That means the rest of it inside's 4. Okay, so now we need to take area of white is, the radius is 2. Means radius squared is 4. So now we got 4 pi for the area of the white. And that gets you 12.56. Okay, so this is outer blue. This is the white area. Now we need the area of the inner blue. Well, the diameter is 2. That means that for this, radius is 1. And that means radius squared, 1 times 1 is still 1. So that means the area of the inner blue is just pi, right? So that would be 3.14. Okay. So the total area from the outer blue in is 28.26. The area from where the white starts all the way in is 12.56. The area for just the inner blue is 3.14. Okay? So, that white part, you need to take 12.56, and you need to take out that inner blue, because that's not part of it, right? You need to take away 3.14, which would get you to 9.42. So right now, we've got the area of the white minus the area of the blue inside of it, and that will get you how much the area of the white is. So this is actually your answer. Okay, that's your answer. So that outer section's really, I mean, the only thing that you really need that information for is so that you can find what the diameter is of the white, right? Or what the radius is of the white, I guess. You had to use the 6 total of the whole thing. The diameter is 6 total, okay? Well, you had to take away the 2 feet for that blue part to get the diameter of the white, and the diameter of the blue is already given. So, I mean, you did need that information, but you really didn't have to find this area of the outside blue. Okay, that's not really important. As long as you knew the diameter was 6 total, and you needed to take away 2 because of that outside blue edges, then that's all you really needed to do for that outside part. Okay, so we did a little extra work. Now, if they wanted you to find the area of the outside blue, you could take outside blue minus area of white, and that would give you all that's gone, and it'd give you the outside blue. If they wanted you to find the area of both blues put together, you actually did have to do it all. You'd have to do the 28.26, and then you'd have to find what the area of the white without the inner blue was, which we found here, and then you're going to have to take that 9.42 away from 28.26, and that'll leave you with all the blue. Okay, so I know it's a little confusing. You can watch this a few times to really understand. Now, this was a really complicated problem, okay? I mean, it takes a lot of thinking to see what they really want you to do there. But that's why we're practicing these hard ones now, so that when we see something in the future, relatively speaking, it'll be easier, right? Okay, good luck on your quiz tomorrow. Study hard. If you felt comfortable during that quiz today, or that assignment, graded assignment today, that's great. But you still need to study a little bit, okay? Because it's not going to be as easy going tomorrow. All right, see you guys.